Well, hello guys, this is Raj from IPRO Games, and in this video of the Unity beginner tutorial series, we are going to talk about rigid bodies, colliders, and physics, materials, and Unity. So basically, the basics of the Unity physics system. So let's get started. What I'm having here is the default scene, and first of all, we'll go into the hierarchy, go right click. Create 3D object, and first of all we'll create a plane. So this plane will be acting like a ground for our physics demonstrations. And next we'll go again create a sphere. Move it up a bit. So yeah, when you create an object, these are primitives. I have explained about these in a previous video, so be sure to check it out. I'll have a link in the description for it. When we select one of the objects, we go to the plane. We see that by default it's having a transform, a mesh renderer, a mesh collider, and I've explained about these components in a previous video. Please be sure to check it out again. Next we have a sphere, and it's also having a transform, a mesh renderer, and a sphere collider. So what the collider is like, you can see these green boundaries around our object. So that's what the collider is. It's like the boundary of an object which determines like what is the hard surface of the object, and it is used by the physics system when you're colliding with something, and that will be your boundary. But unless that won't work, like if I put my sphere halfway between the plane, I'll bring the game window over here, dock it over here, and if I play it, and this button is used to play your game, and our shortcut is Ctrl plus P to play it, and again Ctrl plus P to exit from play mode. So if you see, I'm in play mode right now, and nothing is happening to our sphere. It's in between of the plane, and move it, you'll see that this is so supernatural, this is so unreal. So we'll exit from play mode, and what we want to do, we want our object to act like a real world object and be affected by physics. So there's a component in Unity, and you can go to your sphere, and you can find this add component button in the inspector, and after that search for rigid body, RIGID, rigid body. Yeah, there are the rigid body and rigid body 2D. 2D is for 2D elements, you can know it. And when you click on rigid body, you won't see anything happening specifically changing over here, but I'll explain you what are the properties of rigid body. So first of all, it's having a mass, then a drag, so it's like the air resistance. Then it's having an angular drag, like when you rotate, and that will how much you will be getting resisted by the air when you're rotating. So that's angular drag. Then we have the use gravity toggle. Then we have is kinematic toggle. That's when you want your object not to be influenced. It's having a rigid body, and you don't want it to influence by forces, and you want to move it through a script. Then you enable this option. Then we are having interpolation, and then we are having collision detection. And then I'll demonstrate these options right now. Then we are having constraints like freezing the position, rotation, etc. And then there's an info tab added in this 2019 version, and we are having we can check this during the gameplay to see the information. So now after we have added the rigid body to our object, your plane is also having a mesh collider. So a collider is necessary. You won't be able to add rigid body unless you're having a collider. It adds one automatically. So if you go to a sphere, we're having a rigid body over here, and let's move it a bit up so you can see it's falling. And when we hit Control plus P for entering play mode, and you see that I have enabled use gravity over here, and our sphere falls down to the ground. And if we remove this rigid body component and then we again play it, our sphere will remain dangling in the air. Nothing will happen to it. It's like it's a stationary object. It's not influenced by physics. So the rigid body component is essential for making our objects interact with the Unity physics system. So we'll add one, and now let's see what are these in collision detection options. And first of all, we'll discuss what are the circumstances when you can use these, and what are types of colliders available. So if I add an object, like I can go right click in the hierarchy and 3D object, let's add a cube. Yeah, so a cube gets created, it's having a box collider, and when we go to a sphere, it's having a sphere collider. So you can make out that there are primitive colliders by default in Unity, and these are easy on the system, these are easy to calculate, and the performance is better when you're using primitive colliders like box collider, capsule collider, wheel collider, etc. So, and there's our option for, then if you go to a plane, we are having a mesh collider over here. What the mesh collider does, it takes the shape of your geometry. It's not a primitive collider, and like if you have some, like if you have a figure, if you have made something, if you model something by your own, you can add a mesh collider to it, or you can add two sphere colliders. Like if you're having a round snowman type of thing, you can add two sphere colliders, and that will be called a compound collider, and that will be more easier to calculate than a mesh collider. So yeah, we'll remove our sphere. Bye bye. Yeah, so we are having our sphere over here, and this will be our lab rat. We'll be experimenting with physics on this. So right now, if I move it a bit up and it's having a rigid body, I'll increase its mass something like 10,000. Yeah, please don't mind the lag. I've been recording this, so maybe there will be some lag when I simulate the physics. So let's hit play. Okay, so yeah, it falls naturally. You can see that when we click on our sphere, we have collision detection as discrete. It's by default, and there's no problem. And let's go, like in the next trial, we'll go continuous, or like continuous dynamic. These are for moving objects, so I'll show you the difference. If I go continuous dynamic and I play it, the sphere will fall down again as usual. You won't see any difference here. But if your object is moving fast with a fast enough velocity, it may pass right through your object and ignore the collision, and it will be like unrealistic. So you don't want that. So we'll demonstrate it. We'll set the collision to discrete, and then we'll move our object to something very high, like let's go 600, and we'll have to wait a bit before our sphere comes down. So let's hope for the best. So we can see that our sphere is falling. Yeah, decreasing, it's coming to the ground. Yep, 400, 300, 200, 100. It may fall any time now. Oh my god. Okay, so it is on the ground, it didn't fall down. Why? So we'll try once again, and now our sphere is quite high. We'll increase, so like, yeah, we'll increase its mass. We'll go like 20,000, so that we get a bigger velocity. You could do this easily with a script, but I think that is for some other video, and that will be a bit advanced for this tutorial. So yeah, we'll wait for some time. Our sphere, it's falling to the ground. Yeah, come on, fall baby. 500, 400, 300, 200, 100, and yeah, it passed right through. You saw that. You saw a sphere went right through the object, and it didn't wait. The bullet passed through. So our sphere was having a discrete collision detection now, and we'll try the same thing with our continuous dynamic. So these options are for moving objects. So our sphere was at such a height, and it had a big mass, so as it was falling, it started gaining a lot of velocity, and it was at such a speed when it hit the plane that it passed right through. It ignored the collision. But if we choose a continuous dynamic detection, and we'll see what happens, what's the difference. So if we go to our sphere, we'll see that it's falling. Yeah, it's falling. Come on, fall faster. Yeah, 500, 400, 3, 2, 1, and bam, our sphere stopped on the plane. So we see how helpful collision detection is, but it's more performance consuming. Collision detection, if we set it to continuous dynamic, it's heavier on performance. So if you don't have bullets or fast moving lasers in your game, don't use it. Avoid them. It will be better if you use discrete collision for your small scale projects. So yeah, our sphere is flying. Let's bring it back to its original position. Yeah, move it up a bit. Yeah, so that was the basics of the physics system in Unity. So no, we have one thing left. We have left the physics materials. So like what should we do? Yeah, we'll add. Okay, so now we keep our sphere in the air. It's having a rigid body, and when you see its mesh sphere collider section, it's having a material. So this is like in the mesh renderer component. If you go and if you see that these are the materials, so these are like the graphics. These represent the graphics of the object, and these represent the physics. So how it will can control something, some parts of the physics in this. So we'll go in our project window, we'll go create, and we'll find where is the physics material. So yeah, physics material and physics material 2D. So we'll create a physics material. 2D is for 2D objects. So yeah, we don't need to rename it. And when you will create it, you'll see a bunch of options over here. You'll see dynamic friction, static friction, bounciness. So friction, I think these both represent the friction. Dynamic is for when the object is moving, how much friction do you want. If 0 for infinity, like it won't be able to move. And like then we have the bounciness, like it can be, so dynamic friction, the range is from 0 to infinity, then 0 to infinity in the static friction, and in the bounce 0 or 1. So I'll go 0 for the friction right now because I want to go something experimental. Yeah, so now I'll go on my sphere and we'll find the material section. You can go drag this and put it up over here, or another way is like you click this I and you select the physics material. Select this, press enter. Yeah, so it's having a physics material right now. So what do you think will happen? Let's see. So if I press play, we see that our sphere is bouncing. So that was done by the physics material. And if we like if you want the sphere, if we tilt the plane a bit and we want it the sphere to move around the plane, like if I have an inclined plane and the sphere is rolling it down, and if we increase the friction, we'll see that a sphere is rolling down slower, and if we lower the friction, our sphere will roll down faster. That's a way to test it. So we'll increase the rotation around the x-axis so that it's a bit tilted, and then we can take a ball and put it at the start. We'll raise it up a bit. So yeah, and we can go and decrease the bounciness, and first we'll increase like something like 200, whatever, to something a very high value we'll put over here, blah blah blah. And now if we play, we'll see that, what will we see? Yeah, our plane is inclined and the object is moving slowly, but as it moves, it's gaining velocity. So we'll simulate it once again with a more higher friction, like 10 times, 22000, and we'll add one more 0 over here. Yep, and when we play it, what do we see? We see that yep, it's moving even slower. And we'll try once again with 0 on both. Yep, so let's 0 out these and let's play. Boom, 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 boom. What the? Okay, so we have to put a physics material on a plane too. So we'll go to our mesh render, I forgot that, our collider, and we'll put the physics material over here on our material slot. And now if we play, we'll see that it is moving faster. It's moving faster as if there is no friction. And we can go and increase, if we increase the friction, now that we have added the material on both the objects, we can see that yeah, oh, it's moving slower. So that is the difference. You can make it out. And the bounciness, I've explained it, and the friction combined and the bounce combined, I don't think you'll be using all these. And if you use, please read the Unity documentation. It's very helpful. And if you want to get serious with game development, I highly recommend that you make a habit of reading the manual, of reading the documentation. Unity have done a great job, and they have made very nice and very user-friendly documentation. So yeah, you'll have a good time reading it. So that's all for today's tutorial. If you liked it, please like, share and subscribe, and comment us what you want in the next video, and we'll be explaining about some more basic, like we'll be explaining about animations, lighting. There's a lot of things left, so expect this series to continue or for more like 2 months. No, I think 2 or 3 weeks more. So yeah, we'll be updating content regularly, and after make sure to check out our Blender tutorials. We have put a great effort in making those, so hope you guys like it. And this is Raj signing off. Thank you very much.